Yeah. Hey everyone. My name is Kartik. I am an Android engineer, and I'm also one of the organizers of GDG Sydney. Um, and this is my first time presenting here, and it's good to be. Uh, I do present in Sydney. It's the first time in Melbourne. I think I've done something online. I can't remember, but that's right. I'll be talking about Kotlin 2.0. And this presentation has a lot of QRs, not just one, a lot of them. Most of the QRs point to the same video, but at different timestamps, but you'll see them. How many of you are actually using Kotlin on a more regular basis? Android developers, backend developers, brilliant. So this is probably going to be useful for you. You're not going to learn anything new in terms of syntax or anything. There's no new syntax saying. But yeah, let's see how it goes. So Kotlin is 13 years old now. And if you see any job posting which says you need at least 15 years of Kotlin experience, please call out on their lie. You cannot have 15 years of Kotlin experience. Quick question. Does anyone know why the name Kotlin was chosen or where it was chosen? Like why the name Kotlin? Yeah. Yes, it's from the Kotlin Island near the JetBrains office in Czechoslovakia. It's about 40 minutes drive. So if you ever go there, you can visit Kotlin Islands as well. Okay, let's cover the motivations of why Kotlin K2 as a compiler is being built. Well, Kotlin as a language has been evolving. You have heard so much about multi-platform and new things that are coming with Kotlin, and the language itself has new syntax and new stuff going on. The original compiler, which we are still actively using these days, was made to develop fast things, but the compiler itself isn't very fast. It takes its time. So that's one of the motivations to make compilation time faster. They want to support better multi-threading. They want to support better multi-platform. It works right now, but they have a roadmap where it's even better. And the improved compiler data structures which are used internally. I'll be talking about them briefly in just a while. So let's see what the Kotlin compiler looks like, and we'll keep on diving into each level of it. Most of it is Kotlin K2, and I'll be doing a brief comparison with the current K1 compiler as well, but I'm mostly covering Kotlin K2. Compiler is considered as a black box. Source files, dependencies, flags, and other settings come into this black box, and JVM classes or your binary classes, they just get thrown out on the other end. But let's see what it happens inside a compiler itself. Now you have two parts. There's something called front end and there's something called a back end. Now this is not the front end and back end of a web server. This is just the compiler itself, which is still reading your source program and compiling into a target language. So your source file comes in, front end introduces some sort of semantics, and your backend takes those semantics, and out comes the JVM class files or the JS files or the native SO the binaries that you would need. Looking at front end, it takes the source code as input, as I've said in the last 3 slides. It outputs something called front end intermediate representation. Now, this is a brand new thing in Kotlin K2. So far, there has been something called PSI tree, or forgetting the name. I'm forgetting the name. I'll come back to it. But yeah, this front end also has multiple steps in it. So source code goes into a parser, and the parser generates something called parse tree. It goes through a raw FIR builder, which generates FIR, goes through an analyzer, and then an optional checkers part happens, and then the FIR actually goes to the backend. Let's talk about the parser first. Parser takes in the source code. It breaks down into tokens, lexical tokens, and I'll show you some code exactly what these tokens are. And this creates a parse tree. Now, this parse tree is PSI, Program Structure Interface. That's PSI. And it's a very, very important thing in Kotlin. This is where your IntelliJ or all those IDs as a platform also work. They know how to read PSI. They know how to understand PSI on the go without compiling the program. So PSI is not changing. If they change PSI, they'll have to force everyone to upgrade their tools, and it's good. They're going to get bad rep and a bad backlash. It's a concrete syntax tree, which basically means none of the information, including the useless information from the program, is discarded. So your comments, all your white spaces, everything is preserved at this point. To see or understand PSI in more depth, scan that QR code. It's going to take you to a YouTube video, and it's going to explain PSI. Okay, moving on. The raw FIR builder. Now, this raw FIR builder takes this PSI tree and processes it further into a different kind of tree called the FIR. It generates a raw front end intermediate representation. It's raw because it's going to go through another set of processing, another set of analysis and whatnot until it becomes the actual FIR, which is sent to the backend. It's an abstract syntax tree, which means the user's components of the program are just thrown out and discarded because we don't really need them. It also performs some desugaring of syntax. In-depth details of raw FIR. Same video, different timestamp, so a different QR code. Now, desugaring of syntax, I'm covering 4 broad topics in desugaring. So almost all the if conditions are converted into when. This is called universalization in Kotlin. So all your if conditions which look like this, they automatically get converted into when because compiler wants to have less ambiguous code when it comes to if-else conditions. Your for loops, which are iterative in nature, they become a while with an iterator pattern. That is, again, a desugaring thing that happens at the raw FIR builder stage. The operators like this, they get expanded into the actual function calls. So this is a sugared syntax that we have as developers, but obviously we're still using the .get and .put wherever, or .set in this case. So just to have another layer of unambiguity, the compiler does this for us. And then destructuring also happens at this stage where a single line like this gets destructured into 3 lines, again, to remove any kind of ambiguity. So I guess this gives you a broad idea of what desugaring really means. Now, this raw FIR gets into the analyzer part of the front end, and it adds semantic information about various types, imports, return types. It does type resolution. It figures out what kind of function call needs to be made. It does a top-down body analysis, figures out overload. So this is the most complex stage of the entire front end, and probably the slowest stage as well, because it has to go through so many hoops. It has to jump from one file to another, figure out which is the right import, draw all the conclusions that this is the final program that I have to run, and also figure out that, yes, the code has to be as unambiguous as possible. So all of that happens here. And this is probably the biggest change in the K2 compiler as well, because it has to work with the raw FIR, take in the semantics, and throw out a proper FIR for the backend. Now, the output of this is the front-end intermediate representation, which goes into the backend. But that FIR also goes into something called checkers. This is where any errors, any warnings of your program, they get outputted to you as a developer. Those warnings, those diagnostics are not sent to the backend because there's no point. If there is an error, why send the FIR to the backend? Let's just stop there. It's not like a human language where if I speak in a broken language, you still understand my point. These need to be very, very concrete and very unambiguous. If it's not right, you'll just stop there. Just going back one step, a detailed explanation of the analyzer stage is on that QR code. Again, it's a video. Okay, a comparison between K1 and K2. So far, whatever I've spoken is mostly around K2. K1 does obviously very similar stuff, but in a very different way. It uses the PSI everywhere. It doesn't have the concept of FIR. It holds all the semantic information in this massive map of maps called binding context. So when backend gets the PSI and binding context, it does a lot of jumps and map calls to get the key value pairs and then the further key value pairs, and that slows down the entire process. So all of that gets removed, and all of this semantic information is now part of the node of the FIR itself. So the backend now doesn't have to figure out where do I look for more information. It's right there. Sure, it makes the data structure bigger, but it makes the compilation faster. So you would, if you are using K2, you would notice an increased RAM usage. Like I said, because of PSI and binding context, a lot of jump instructions happen because it's jumping from one data structure to another and figuring out where to go next. But in K2 frontend, jump is not used that often. It is mostly used when it has to refer other files to figure out semantic information. But once that is figured out, it's all done. No more jumps required. And the culmination of all of this, as per JetBrains, is that K2 frontend is about 3 times faster in getting the raw the FIR out to the backend or any output out to the backend than the K1 frontend. I'm going to show a demo of how to use K2, but it's a very tiny program, probably 4 or 5 lines. So that's not a good benchmark to show you the difference in speed. But if you were to use K2 in a complex project, you might notice some difference. Okay, talking about backend. So K1 backend takes PSI and binding context, but K2 backend will take this FIR and pass it to something called FIR to IR converter, which is the intermediate representation. The previous backend takes the PSI and puts it through PSI to IR conversion. So IR remains relatively unchanged, but the way the IR is used is changing. So the backend performs further processing on this IR and then throws out the JVM classes and whatever target code you want. So with K2 backend, this is the new logical structure of how compilation happens. Depending on what target you're targeting, it will take the IR, and that IR will go through a bytecode generator or JavaScript generator or your LLVM bitcode generator to give you the correct files. And now you might have heard about Kotlin WASM as a target. That is coming in as well, and that's the first backend which only does FIR to IR and then takes that IR and goes forward with it. Every other backend over here has dealt with PSI to IR before. But with this structure, you can see a lot more code, a lot more semantics is being shared in the backend itself before it gets into specific of stuff. The very specific stuff in JVM backend is just JVM bytecode generator. So it makes it faster for the backend as well to understand the context. And it makes it easy for JetBrains as a language producer to allow other developers to use this IR and maybe create plugins for IDs and things like that, which so far has not been possible. If I'm not totally sure if this is correct or not, but JetBrains plans to release an IR API or a API spec at least, so that you can create backend plugins as well. So yeah, the backend goals were to share logic between backends, like I said already, support new language features, but they're not looking to improve performance of the backend as such. They want to include more platforms going forward. Whatever new platform comes out, let's say, they want the IR to be able to get converted into that particular target, and allow the development of compiler plugins for backend. As a comparison, K1 backend uses PSI and semantic information everywhere, whereas K2 backend uses the new shared IR. JVM and JS backends, respectively, in 1.5 and Kotlin 1.6 have switched to using the new FIR to IR, or at least their experimental backends are now available. So, and they work independent to the front end, which is experimentally available in 1.9. Okay, detailed explanation of backends in the Kotlin compiler, another video. I see people are scanning, so I'm gonna wait. All right, moving on. Thank you. That's all right. I'll be publishing these slides. These are all links to various videos or articles where you can maybe read more and understand the entire structure. I'm just touching the surface. It actually is much deeper. And one of these crash course on the Kotlin compiler, that article and the subsequent video explains the parser stage as well in a very detailed manner. Okay. Now I'm going to talk about the Kotlin language as well. The 2.0 over here is a bit misnomer, but there are some new structures that are being developed and released with Kotlin. And they will be 100% stable when 2.0 comes out next year. So what's new for developers in Kotlin? We've seen what's new, but what's new for developers? I'm going to touch these 4 new things. So we've got something called entries property of an enum class, data objects, range until operators, and secondary constructors for inline value classes. Ooh, heavy words. Entries properties will replace values function. If you've done this before, color.values or enum class.values, you can just simply do this. What it does is it creates an immutable list of enum objects, whereas values creates an array list. An array list by nature is mutable, so you can actually change it and introduce a bug. With this, you can't. It's immutable. Compiler is doing things for you now. And then whatever filter operations or predicates you have on that collection, they still work because it's still a collection at the end of the day. It's just immutable now. So that's entries property. For data objects, very similar to data classes, objects are now getting the data keyword. So the compiler will generate the toString, pure singleton objects, because once the object is created, you can't change it. It'll generate the toString equals and hash code for you. What it will not generate is a copy and a component function like data classes, because they're singleton. So you can't really copy a singleton, or there's no component to it because it's an object. It's not a class. It doesn't have properties. Just as an example, and I'll be running this code in a short while. Sealed interfaces, you can have regular objects, and with Kotlin 1.9, the IntelliJ IDEA linter will actually tell you that this could be a data object. Please use that. Range until operator. It's a new operator which looks like this, and it's aimed at making this kind of code easier to understand. It's not clear what exactly is going to be the range of this for loop. Is 10 included in it or not? We can't be sure until we actually run the program. Or if you've run it enough number of times and you've had that headache, you know exactly what it's going to be. But with the new operator, you're sure it's going to stop at 9 because there's no less than equal to. It just stops at 9. 10 is not included. So it's probably a syntactic sugar, and when it goes to K2 compiler, it'll get resugared again. Secondary constructors for inline value classes. Now, Kotlin has a limitation with inline value classes that it must have a single parameter constructor. Otherwise, it won't work. How many of you know what an inline class is? A few people. Okay, so I'll just tell what an inline class is. An inline class gets replaced as it is to avoid overheads of class and object creation when you try to create a new object of that class. So when you create the object, the class definition, all of it just gets replaced over there instead of creating a memory allocation for that class blueprint and then creating an object, all of that. With the new Kotlin 1.9, you can now have multiple constructors, but you still need to have that one single constructor parameter. That's a must, but you can have secondary constructors with as many parameters as you want. Now you have access to individual parameters, so you can actually use those constructors to check those parameters individually rather than take one parameter, break it down, and have a complex logic. You now have access to each parameters. So something which looks like this can be expanded into looking like this, and just a short example of what it could look like. Your use case might be different. Okay, what does Kotlin 2.0 mean for Android? The experimental support for K2 compiler is happening. You can start using K2 already, but because K2 for Kotlin itself isn't great, there's no guarantee it'll work great with Android either. KSP, Compose, and Android Studio, they do not fully support it. Last I checked, they said it's going to be at least one more year, and but it's getting there. They're working on it with JetBrains. You can set this in your build Gradle file, and that will start using Kotlin 2 in your Android projects. But when it comes to pure Kotlin Gradle projects, all you have to do is put that one line in your Gradle.properties, or if you're running via the terminal, set that flag, and the compilation of that program will happen against Kotlin 2.0. For this to work, though, you have to have Kotlin 1.9 installed. That's where the experimental K2 frontend and backends are. Further readings just about Kotlin 1.9 and what's new in Kotlin. And just to try out the K2 compiler, I'll be publishing these slides. These are all hyperlinks. And that's the end of my slides, but I'm going to switch to IntelliJ now. Okay. Is that font size good enough? Is it visible up there? Okay, I'll increase it. I see a few people saying no. Is that better? Somewhat. Okay. It's gonna get ugly now. Is that better? Okay, perfect. Enum entries. Let's see that first. Why do I have so much white space? Well, doesn't matter. So I have an enum class like I showed on the slides, and I can print the color values or I can print color entries. And that's too small, but it says enum values is recommended to be replaced with enum entries since 1.9. So IntelliJ and all these tools already have support for linting this problem out and giving you a warning. It's not an error, but it's a warning. And if I run this program, oh, I should have run from it. Okay, so when I print out values, it just puts the hash code and the object class definition name. But when I print out entries, it actually prints out the actual entries because it's an immutable list of objects, not an array list. Array list doesn't have a proper support for toString. So that's enum. Data objects. I've got the sealed interface over here, and I've got the 4 objects. Now, the lint warning over here says sealed sub-object can be converted to data object. And like you can do with Android Studio and other tools, you can just use that contextual menu to change that. But I'm just going to run this and show you exactly what it produces as an output. So the 2 objects, north and east, are not data objects. So they print the name as well as the hash code of it. But south and west are data objects. So they have proper toStrings and they only print the name. I'm not doing anything special over here, just calling the toString on these objects. That's data objects, enum entry. Oh, sorry, inline classes. Now I've got to do some trickery over here. I'm going to run the first one. I've got this inline value class, and I'm just creating an object over there. And with the init, it'll just print out the name. Now, if I run this, the output is super predictable. Australia created. Now, if I change the class definition completely, and okay, class definition is changed. Now this is the class. It's got a secondary constructor here, which does call the original constructor. And I've got two objects that are getting created over here. What do you think will be the output of this program when I run it? Wrong answers accepted and preferred. Huh?
Two lots of Australia created.
Two lots of Australia created. Okay. Anybody wants to say that Katie is wrong? Nobody wants to say Katie is wrong. All right, I'll just run the program. It is two lots of Australia created, but then it also says Canberra created because in the second constructor, I've got the println. So the first Australia created comes from the first object over here on line 2. Because it doesn't have a second parameter, the second constructor never got called. But the second object over here sets a value for the uses the secondary constructor, so that this will get executed. But always remember that your super class is created first, so your init gets called first, which prints Australia created and then Canberra created, and that's inline classes. Now this one, oh yeah, this is a cool one. I have no idea how to increase the size of this side panel over here, but there's this plugin for all IntelliJ tools called PSI Viewer, which can go line by line, token by token, and show you the PSI tree on your right-hand side. So it starts with package directive, but because I don't have a package directive, it's just empty. Import list is empty, and then fun keyword, it's a PSI element called fun. Then there's an identifier, then there's a block, a whole lot of things. So if you ever are curious about how the PSI is created for the program that you're writing, just install this plugin and it just starts working. But I'm going to compile this program against Kotlin K2. And there's a way to confirm that, yes, your program is indeed compiled against Kotlin K2. So I've got this Gradle task. I've got these two. The more important one is the second line. I've set the flag to try K2 to true. And if I run this task of just compiling it, it says that, where does it say? Wait, no Kotlin compilation tasks have been run because it's already up to date. Need to delete it. I'll just delete the build folder. Okay. Language version 2.0 is experimental. One-on-one task has been compiled with Kotlin 2.0. So this confirms that, yes, your flag is working. And if you've got a complex program, this will tell you that your program is either completed successfully or not. And then it'll tell you against which compiler. I still don't have Kotlin 2 installed as such because there's no installation for that yet. I'm still running Kotlin 1.9. I'm still running Kotlin 1.9 against a JVM 17. But this includes the new experimental K2 backend and frontend. So I've told it to try and use that. Yeah, that's pretty much it. Yeah, that's it. And thank you for listening. I'm open to questions now.
Any questions for Kartik?
Yeah.
Quick question. So version 2, that's a major version bump, right?
Yep.
Which means you can technically remove features.
Remove features. Yep.
What would be the one feature from Kotlin 1.0 flags you would get rid of?
Me?
Yes.
Nothing. I don't want to get rid of anything in Kotlin 2.0, but it's an interesting question. It is a major bump, yes. It's migrating to 2.0. There won't be any 1.10 or anything. but it's going to be backwards compatible. All your existing programs, you do not have to significantly change them. In fact, they're trying that you do not have to change them at all. Just tell the IDE that you need to use this new compiler now, and JetBrains just wants it to work. That's the idea. So they're not introducing new language features. They're not taking out language features. They're just making the compiler faster. Yes.
You mentioned Compose is not going to be around for, for a while. So whereabouts does Compose fit into the Meetup K2? Like, is it a front-end plugin? Is that what it?
Compose.
Yeah.
And the Compose compiler as well.
Compose compiler. Yeah.
It's not a front-end plugin. It is, well, it's at a weird state, right? It's a compiler in itself, and a lot of people have asked question, well, if it's a compiler, why can't it just do things that it asks us to do? Just figure things out on its own. But then it's also a compiler plugin because it gives superpowers to the compiler. And JetBrains' view is that all existing compilers will continue to work because they use the PSI API to work. PSI is not changing. It's just that PSI is not being dragged along through the entire journey of compiling it. So a compiler will continue to work. Maybe they'll enhance the compiler and even the Jetpack Compose compiler to better support K2's new infrastructure internally. But that remains to be seen. There hasn't been any announcement on that yet.
That's it.
Oh, thank you. You can get the slides on that QR and then click on the links. Thank you.